Today's Pentair Water Break is going to be discussing how we remove iron using AIO treatment centered around the 2510 AIQ valve that we're launching this year. Now, the thing about chemistry, we do a lot of separation work, which is separating one compound from another. Ion exchange resins, we're used to in softening, directly pull ions out of the water. That's a direct chemical way to remove it. But that can be complicated, right? One of the more simple techniques that chemists like to use to separate things is precipitation and filtration. Why? If we can turn something into a solid, we can use relatively low-cost technology, filters, to remove that debris, separating it permanently from the liquid. So we leverage techniques in chemistry to precipitate lots of things out to isolate them from solution. And that's what we're doing here with AIO and the 2510. We're wanting to make solid iron oxide or hydroxides and precipitate them out and filter them out. But chemistry, like the real world, is often a little more complex than we want it to be. But understanding some background chemistry will simplify this topic and have you understand why you're using the media as you do in your market with these systems. So that being said, this is the end goal of AIO, is to make iron hydroxide, the familiar red version, and you get a black colored precipitate out of iron when you include sulfates into the mix as well. Different hydroxides here, like iron +3, can form hydroxides. We don't run into that circumstance a whole lot in residential water treatment or well water treatment, but you may run into this form of iron oxide as well. But once it's in this form, it's real easy to use a standard filter or even an activated carbon tank or your media bed for your AIO system to filter this debris out. How we make this debris matters to us. We want to make big chunks of iron so it's easy to remove. And that's what we're talking about today, looking under the hood. Because once we make that particle size, we can filter it out. This is a 25-to-1 DGD filter. And one of the things to note about this is you can see here, this is the 1 micron core. You're still getting some fine particulate through. And this is iron that was formed at a much higher pH and very finely. And we can filter that out. The goal when we're doing AIO is to make as big a chunks of material as we can to make it easy to filter out. So when we oxidize iron in water, we are going to do two things. We're going to pull hydroxide out of the water. Iron hydroxide is the rust we're trying to make. And we're going to leave the other hydrogen from the water in solution. And that is now acid. Acid is hydrogen ions in the water. So for every molecule of ferric iron we reduce, we're going to create 2 ppms of acid. So this tells us that we have to manage our pH in order to maintain iron precipitation. Why? We need OH in the water to do this. So if you don't use a pH management media and you're trying to remove iron, you're going to drop the pH in that water. And sometimes, depending on the concentration, precipitously. So we want to make sure we're managing this pH relationship. Why? Ever pour a little vinegar on some rust and watch it bubble? Well, if the water's pH drops low enough from oxidizing the iron, we're going to redissolve that iron back in the solution, which isn't good because we're trying to remove it. So it's about understanding that we're making acids when we're making that rust that we're going to filter out. And that informs you why we have the medias we do. One of the other things you need to understand about this tool is it's based on the solubility of oxygen in water. Gases in water are more soluble when the water is cold and less soluble when the water is hot. So you can see here, this is a chart of the solubility of oxygen in water. As we approach 80 degrees, we get drastically less amounts of oxygen dissolved in our water. So if I'm someone in the southern United States or in the tropics or someplace traditionally warm where you may have outside systems, I need to account for this. I may have to regenerate more frequently in these circumstances, or ensure my unit is placed someplace out of the sun so it doesn't cook, so it performs better in that environment. Simple things like installation envelope will matter here. And if you're up north, if you're in, let's say, Calgary, where they have lots of dissolved iron in the water in some locations, you're going to get really good performance out of these units because the water is colder and it's going to dissolve better. And by the way, if you have any questions during the presentation, feel free to ask them now, either in the chat or by raising your hand. So when we look at this chemistry, you can derive some rules of thumb about how to oxidize iron and produce rust in water. And this is garnered over decades of field experience and hard scientific research from the folks at the U.S. Geological Survey exploring this phenomenon, as well as we're being drilled across the country. So for iron to be oxidized, pH and alkalinity play an important role. Why? pH, we needed above 7 to have extra hydroxide in the water so we can precipitate the iron. We need alkalinity in the water, Tums. This is our buffering system to resist that pH change. So depending on how much alkalinity I have in the water compared to how much iron, I may not need to manage my pH. In other cases, I will. In some cases, I shouldn't. And that's important to understand here. So the rule of thumb should be to use AIO effectively is you want a starting water between 6.5 and 8.5 in the tank and an alkalinity above 100 milligrams per liter to absorb the acid that's produced, to buffer it. You're also going to in this process, this number will come down in the final product of the water because we're breaking it down to CO2 and gassing it off. So when the iron becomes oxidized, something is reduced. The alkalinity becomes reduced by the acid produced from the oxidation of iron. The ideal pH range to remove iron is 7.2 to 7.5. Above 7.7, we may start to form smaller and smaller particles that may travel through our filter bed. And if you are above 8.0, especially 8.5, you're going to create a very, very fine particulate, almost like talcum powder, that will blow through most filter media beds, even 3-micron beds. So how we make this iron leads to how easy it is for us to remove. So the ideal alkalinity in your water should be 100 milligrams per liter, ppm, plus 3.5 to 5 times the parts per million of iron. So in my system at home, I have 2 parts per million of iron. I need at least 100 plus 5 times 2, which is 10. I want 110 ppm of alkalinity in my water to resist the pH change from me oxidizing the iron. So what does an air injection system do for us? Well, it takes our iron treatment, puts it into a one-pass system where we're using a generally considered safe reagent, air. And we have to remember that air is only 20% oxygen. So only 20% of that bubble trapped in your tank is there for oxidation of iron. We want to remember that once that tank is reduced 20, that air bubble at the top is reduced 20%, that's when it absolutely needs to be regenerated. And you can see that it's there. That bubble should remain trapped there throughout the service cycle, even if the oxygen is exhausted, because the rest of it, 80% of it, is nitrogen. So this is smaller footprint, fewer things to go wrong, no chemical pumps, no chemical storage, which can be rather a liability risk in family homes, or just management or infrastructure from fumes. You don't want your chlorine injection right next to your house furnace because the fumes are going to eat up your furnace, kind of stuff, right? You want to manage that. This simplifies iron removal and removes any of those risks involved with it. Has the same operation as a standard softening valve. The only difference here is instead of drawing brine, we're drawing air through a dual check valve, so it prevents the air from going back out the port. And our regenerant is air, or the atmosphere. Now, the service cycle is going to start after you get this thing regenerated the first time. You are going to get a bubble trapped at the top of the tank and possibly even partially into the media. But more importantly, if you've ever seen a glass of soda with all the CO2 bubbles clinging to the side of the glass, it's important to use medias in these tanks, even if it's a filter media, because those bubbles that stick to the side of the glass, the same behavior happens here in the tank, sticking to the granules of media. And you actually trap more air on the media below the air bubble in the water line than you do above it. So the use of media definitely augments these products and their performance. What media you select is going to be based on your water chemistry. Now, when we think of backwashing AIO, this is critical because we have to understand we are making debris, dirt inside these units, and also handling the incoming dirt load. I would suggest that if you do return visits to validate operation, you evaluate backwash at the time you do those visits. If you have dirty water in the last 2 minutes of your backwash, you need to add 5 minutes to your backwash time. That adds 1 bed volume of water through the tank if your flow controls are sized properly. Why? We need to get that dirt and debris out of the tank. If we don't get a good backwash, we're going to leave dirty water up inside the valve, and when it switches into service, you may get a little bit downstream, but to the life and operation of the valve, you're leaving dirt and debris to drag back and forth through that seal and spacer stack, and now it's a hard particulate of rust. So make sure you evaluate your backwash on AIO. Make sure it's getting the tank clean between regenerations, because we don't want to leave that iron in there to be a source of food for iron bacteria, and we don't want it building up in the bed, period, as that builds up over time. Now, the air draw, this is just like your brine draw step. It comes out of the box program for 60 minutes, but how you tune this to your tank size is by watching the first regeneration, time it till it gets to the bottom, and add 10 to 15 minutes to give the air a chance to stick to the wet media. You don't need the full 60 minutes here. We just include that in the base stock programming to cover the full range of tank sizes. My 1 cubic foot unit here at home is set for 27 minutes to drain the tank plus another 10, 37 minutes. Okay, this uses a number 2 injector, so it's drawing in large amounts of air. If you have issues with iron bacteria in the area, you want to make sure that the area this is drawing air from is relatively clean. If it's a wet, musty basement, you may want to think about adding an aftermarket HEPA filter to the inlet to prevent bacteria from being drawn in. We are drawing in atmospheric air here. The injector assembly is integral to the treatment and the valve and not outside where it's prone to leaking. So we're drawing through the injector inside the valve, not external. It's not hanging out in space to get hit by anything moving by as well. Now, rinse to service. This is after we've drained the tank. We want to rinse this and flush and fill the tank, which then pressurizes that air bubble at the top of the tank to the to the pressure we have in our water supply line. So this will actually trap more oxygen with higher pressure water systems. It's just how that works. And when we rinse to service, you're going to hear cascading water down through the tank. In the service cycle and in rinse, this is a natural noise to get. Why? We're dropping water through air onto a watery surface. If you have very sound sensitive customers, you may have to manage that issue there. It's really not really all that loud at all, but I have had customers that were extremely sound sensitive in my past as well. So you may have to cross that bridge when you get to it. Now, that's a sign that the system is actually working. Now, since we're running water through a gas and picking up that gas, we're dissolving bubbles in it. If the system is working well, you're going to see some effervescence at the tap. We're going to get some air bubbles out. That's natural. If you have some bubbly water that comes out, those bubbles will disappear in short order after standing. It's no different than, let's say, a Perrier or something like that in experience. But that's the trade-off of using a generally considered safe reagent like air versus having potassium permanganate or chlorine or hydrogen peroxide injection systems in a home. And it takes some of the burdens of compliance for driving on the road for dealers away. The other thing we want to know about the service cycle is on backwash. You must anchor the backwash lines on these systems because when we go into backwash, we are going to be pushing air and water out together, and that makes a whole lot of competition for getting out the pipe first, and it can cause some splashing and moving of pipes around. So on these systems, you must anchor these units down in place. Mine is just hard piped in, and I don't need to do anything other than hard pipe. It doesn't jump around, but I would anchor it if it was in a customer's home for sure. Make sure you're anchoring these lines when you install them. Now, we've added a direct programming feature for AIO into the AIQ menus. But here's the basic appearance to the new AIQ controller. You're going to get your service rotation right here between gallons remaining, flows, peak flows, date, and your contact information here. And when we go into this just shows the program settings. But once you get past the initial program settings, you're going to have your cycles that you can pick. You can pick softener, filter, or AIO, where it's labeled air draw instead of brine draw. But understand that this is a filter setting with one additional feature. So this way you can have it congruent across your product line. It's an AIO, but it's really a filter with a special step, or a softener without brine refill, if you want to think about it that way. Now, a lot of these medias, the oxidative medias like Catalox and mag oxide like berm and things like that, or even activated carbon that you may use in these applications may require a soak time to get them prepped. Well, here you can use our custom feature to program steps in any order you want on this, but you can also use our startup feature in the menu and create a startup cycle to soak the carbon for 24 hours, go into a rinse and a backwash, go through that. And once your startup sequence is finished, it will revert to the programming for normal operation. This can save you a lot of time on site or even in your return trips to do a validation in that setup. You can precondition the media by programming it on the unit, which I love as a technician. The diagnostic menu, what's a little bit different about this menu than past is you're going to get a couple of things that you didn't get before. successful regens and aborted regens. This is going to catch those failure to move on pistons and things, sorts of failures, which can happen in AIO if we're not managing our backwash properly. We can leave that debris up in the valve body and lock it up. We want to get as much life out of these as we can, so manage that backwash and understand you're going to see that here. You can restore backups on it. You can have continuous flow, detect issues for those slab homes down south, and you can get into your view settings, all the standard stuff. But I want to keep talking about the application of AIO more so than the other traditional stuff. But all the traditional error logs and data is here as well, and it can be exported. Now, iron treatment happens in reality, and reality is filled with a lot of unexpected chemistries that we didn't want to think had to dealing with. Oh, I'm getting drinking water for a home, right? So some of those challenges start with selecting the media. The media in my house that I use in my AIO here in Northern Illinois is activated carbon, because I have 2 ppm of iron. My pH is around 7.8. It's in a good range to produce rust. And I have 300 parts per million of alkalinity. So I have plenty of buffer. That's why I get to use activated carbon in mine. I'm using that acid to lower my alkalinity and lower my pH. The pH that comes out of my AIO in my setup is 7.2. My alkalinity is dropped down between 180 and 200, and no iron. But I also get the benefit of organics removal in that same package. So understand that there's wiggle room for the medias you use. Now, let's say if you're out in Maine and you've got a pH of 5 coming into your home, magnesium oxide medias don't function well below 6.0 pH because the acidic water starts to break them down. That's where you're going to use something like calcite. That's a sacrificial media. You're going to want to use a dome hole tank with that application to refill, or a Corsex, which is a mix of mag oxide and calcite, right? That way you can elevate the pH and your alkalinity at the same time, so you can then oxidize the iron. So lots of different, medias you can use here. You can use catalytic carbon. Well, if you're trying to get rid of hydrogen sulfide, even though we can talk about that today. And then there's the specific zeolite, like Catalox and Catalox Light. These are manufactured versions of green sand and berm. And these go down to 3 micron. So you may want to be able to capture more of your debris in using those medias while you manage your pH as well. So understand the tool you're using, and maybe you can kill more than one bird with one stone in this situation by applying the medias to your water qualities appropriately. And pH management is not applicable to every iron removal scenario. It just applies to most of them. The other things that can be problematic about iron formation and rust formation is colloidal iron. This is when we make iron at a very relatively high pH in water, above 8.5, and it's so fine that it blows through half micron cartridges. And the only solution to this sort of problem is a UF filter. An AIO will not remove it. This water looks colored, but it's not from dissolved iron. It's from very super tiny suspended particles, kind of like dust floating in the air, but it never settles out. The other one that's a little more problematic, and this tends to appear in shallow wells or wells with steel casings that cracked up near the surface at some point in time. The most common organically bound iron that you and I are probably familiar with is hemoglobin in your blood, where an organic molecule, your blood, uses iron in the center of it to stick oxygen on and off. Well, organically bound iron in nature tend to be bound to things like tannins and humic acids, and these are very, very difficult to remove. Why? You have to either break down the organic molecule and remove it with carbon or use it directly, but you're dealing with anions and cations here and metals mixed together. You need to understand what's in your water. An AIO system will not remove tannins well unless it's coupled with an appropriate technology. And in most cases, you're probably going to want to use a stronger oxidant like chlorine or hydrogen peroxide to attack your tannins. But discuss your water qualities and what medias to use with your distributor as well. So realize this can be very, very complicated to remove organically bound iron. This stresses testing in the field. And then there's our wonderful friend iron bacteria. If you have iron bacteria and it's in ones and twos, it's not a large colony, you may want to consider suppressing it before you let it into your AIO, or adding antibacterial medias to your AIO applications. Why? This stuff feeds off of iron in the water for its biological processes, and it likes living in the dark. Well, an AIO filter creates wonderful conditions for this bacteria to grow in because we're dropping all its food out right on top of a filter bed where it's stuck to too. So make sure if you've got iron in a well that you test for iron bacteria or familiar with it in your community. If you have it, you may want to suppress it before it gets into an AIO, or choose a dual pronged approach to kill bacteria and oxidize iron, which can be tricky to do. So evaluate your water before you make technology selections, especially if you have stuff like iron bacteria in your water system.